Okay. Hello, everyone. Good afternoon, good evening to everyone who joined us today. A very big thank you for joining us in our webinar that is titled Mastering 4G and 5G Telecom Threat Intelligence. And as you know, we're going to be having three experts walking us through this presentation webinar today. It's Igor and Sergey who head our research initiatives, and then it will be followed by Kirill, who's our product head, all guys with extreme telco and telco security expertise. So it's going to be a very insightful webinar. And before we start, I was just going to be walking you through a little bit of to-dos that we all can follow so that we make this a very engaging session. So through the webinar, I am Sonali. I'm going to be your host for the evening. And if you feel there's any glitch that you're coming across, experiencing, you can just shout out to me in the chat window right here, and I'll come and help you. The other thing, if you feel the chat window is not accessible or you're finding some kind of a lag there, you can always use the raise of hand icon, and I'll come and address your query. The other thing, while we have three power-packed speakers walking us through this threat intelligence webinar, if you may have any questions on the go, I will highly recommend that you start posting those in the chat window. Why? Because we can effectively use our time and we'll start responding to your questions on the go. At the end of the webinar, about 45 minutes from now, our experts are also parked some time for a very dedicated Q&A. That will be another chance for you all to get your questions addressed. And last but not the least, at the end of the webinar round, we are going to be having a recording of this whole session, a video file, which we are going to be emailing it to you after the webinar. And with all this, I think I will open the floor to all the three gentlemen and they can start it. But before that, if and after the webinar, if there's anything else you want to know from us, a security gen, this is the contact ID where you can reach out to us. With, I guess, much further ado, Igor, Kirill, Sergey, gentlemen, the floor is open for you all. And I'll stop sharing. So, yeah, Igor, over to you. Yes.
Thank you, Sonali. Can you see my screen?
Absolutely, you're audible to Igor.
Okay, so now let's start. Hello, everyone. Thank you for joining us. But let's still wait for a couple of minutes for other participants. Okay. So, hi everyone again. Thank you for joining us. The topic of today's webinar is Telecom Threat Intelligence with using of MITRE FiGHT framework. My colleagues and I will talk about what is it, consider examples of MITRE FiGHT user gauge, and also analyze some examples of already known attacks using this framework. So a few words about who we are. So I'm Igor Pigolitsyn, 5 years in telecom security, working at Security Gen in the position of telecom security researcher, responsible for 5G security assessment in our company, and also conducting telecom security in 4G, 5G network for mobile operators for many years. And Kirill, please, over to you.
Hello, everyone. So my name is Kirill Puzankov, and I'm 10 years in telco security. So currently I'm a product manager in Security Gen. So I've been exploring telco threats and vulnerabilities, starting from the SS7 and up to 5G. And right now I'm helping in growing the solutions for protection of mobile core networks, and as well as provisioning of visibility of the network security posture. Sergey.
Thank you, Kirill. My name is Sergey Puzankov. I engaged in telecom security from 2013, and I started from research of SS7 security protocols, then discovered some bypass techniques that allowed us to know signaling better. And during these all these years, I was a contributor to non-commercial organizations such as JSMA and ITUT, and took part in different security conferences as a speaker. So Igor, please continue.
Okay, thank you, guys. So, well, first of all, let's quickly remind what the MITRE ATT&CK framework is about. For a detailed description of all the action taken by the intruders during attack procedure, there was developed MITRE ATT&CK framework. There are actually 3 separate matrix for enterprise, mobile, and industrial control systems. It's a good real world knowledge base of adversary behavior. It's also had free access, and this database is constantly updated over the time, 2 times by 1 year. This framework consists of 6 components. First of all, it's a matrix that we showed before. Then it's a platform which you can see in interactive mode for your purpose, like investigate some security incidents or learn something new. It's also tactic, techniques, and procedures. This is what matrix consists of. Groups. There is a knowledge base of all existing hackers groups. Software is a side section with the well-known examples of malicious software that hacker can use in their attacks. And mitigations describes how we can protect our infrastructure from a specific attack. Let's move to general topic of this presentation, MITRE FiGHT framework that describe 5G security threats. This is what matrix looks like for now. As you can see, the structure looks pretty similar with the attack matrix. There is a table with the columns called tactics, and rows, it's techniques. As well as MITRE attack matrix, some of techniques has sub-techniques. Also, some items move from attack matrix, and rest of techniques is unique for 5G. So how can this framework be useful for everyone in telecom security? Well, first of all, it's unified language for security network professionals. Good communication between departments is critical in big organization, and the same story with executive reporting. Like professionals can use FiGHT to translate technical details into strategic insights for leadership in their company, focusing on how specific tactics and techniques could impact business objectives. Second one, during security assessment, professionals can use the FiGHT matrix to conduct a security gap analysis. identify what defense you have in place and where you are lacking. It's also helpful to review your existing security controls and solutions to ensure that they cover the tactics and techniques outlined in FiGHT, identify gaps, and arrange improvements and controls. Next point is about prioritizing controls. You can align your security controls with the FiGHT techniques that are almost relevant to your industry field or specific threat landscape. Next point is about threat detection and incident response, like implementation, security information, and event management system solution that aligned with FiGHT helps to facilitate real-time monitoring of security events. This approach is also applicable for detection rules. You can utilize the framework to develop detection rules for your SIEM system. MITRE FiGHT framework as a comprehensive knowledge base of adversary behavior helps to train also red and blue team experts, or like your blue team can use FiGHT to identify and defend against attack. And the last point about vendor evaluation. As a company, you can use framework to compare the capabilities of different security tools. It could be helpful in contractor assessment field when working with third-party security firms. Use FiGHT as a baseline to relate the expertise and capabilities. Now we have given only some examples of possible use cases of this framework, so you can define for yourself the areas where MITRE FiGHT is also applicable for you. The FiGHT knowledge base is constantly updated by multiple contributors and industry players. MITRE has included all available information about the possible behavior of the attacker and ensures against them. At the same time, not all techniques are marked as observed. We also can see techniques that labeled as a theoretical or proof of concept. As a part of our activities at SecurityGen, we have to compare our understanding of possible attacks with those in FiGHT matrix. So we have sorted all the techniques and sub-techniques into the following groups. 83 green techniques, we know how to verify, emulate, or exploit them. We know how to detect them. And we consider this as a covered, meaning it's likely that we conduct security assessment for our customers in production network and in a test bed. We can verify if networks are exposed to this and suggest particular remedies. There are also techniques and sub-techniques that we assumed we can emulate or exploit. And we believe these are realistic, but we haven't not yet been able to execute them, even in the lab or for various reasons. This fall under the requires verification category that marked as yellow. And the rest of that we don't know how to approach, mostly due to the lack of information or knowledge. There are 45 not yet covered. And now let's try to apply the described framework for analysis a real attack in 5G. We will go through the main stages of the attack and consider what techniques should be applicable for that. The final goal in our example of intruder, in our case, it's performing denial of service attack on a victim subscriber. So first of all, I should say that preparatory part of the attack take most of the attacker's time. The preparation period includes such tactics as reconnaissance, resource development, and initial access. Let's start with the first one, reconnaissance. For the beginning, the attacker conducts reconnaissance for mobile network operators of the victim subscriber. So to do that, he should discover IP address of 5G core elements. Basically, it's enough to find out the address of network repository function, since this network functions store all the active profiles of 5G network instances for standalone core. Our intruder also needs to prepare some tools to carry out successful attack. There are many ways to do this, starting with generating your own framework in any programming language using Open API specification, or following simple way like use popular testing tools such as Burp Suite or Postman. At the next stage, the adversary should think about the attack vector on the network. You can get into the network through compromised roaming partners. Roaming partner is an important attack vector even through encrypted tunnel. Attacker have some possibility to send malicious traffic that can affect your network. Or even more, the attacker may already be in IT infrastructure and then using various methods get into the signaling segment in the operator's network. He can do this directly to the service-based interface. Next stage, intruder conduct exploration of network in which he finds himself by getting all network functions profiles. Using these profiles that adversary received from NRF, he find out the addresses for all deployed service. At this stage, the attacker knows the entire network structure, which services are active, what version of API is used on network function, and many other things. So, in the progress of registering a subscriber on the network, the AMF network function that's serving our subscriber put information in UTM, it's a storage in 5G network, about the status of the subscriber, supporting features, writes down his own AMF ID and other information. And of course, the intruder can get AMF registration profile from UDM. On this slide, we can see an example of the execution of this HTTP GET request. In addition to other information, here we can see unique deregistration callback URI that typically used when UDM initiates user deregistration. But if attacker also executes this HTTP request registration for our subscriber on AMF, current session will also be cancelled. After the attacker received 200 code response, subscriber will be deregistrated, and that it will take some time for the phone to do new registration. This type of attack can be executed automatically with some period like 1 time per second. In this way, subscriber will lose the 5G connection for the entire time of attack. I should say that this attack conceptually similar to cancel location request attack in 4G network. Well, in this example, we have decomposed the 5G attack into stages using MITRE FiGHT framework. So now let's see how the same approach can work in SS7 network. Sergey, please, over to you.
Yes, thank you, Igor. Colleagues, now I would like to tell you about our experience, how we investigated not on a 5G network, but on elder junior generations. But anyway, we would like to demonstrate how this MITRE attack matrix may be mapped on the different or other generations. So now we received a request from one of our customers that they face the incident, fraud incident. The clients of banking accounts were withdrawn, but intruders, when they did the malicious actions, they were able to intercept SMS messages with one-time passwords from this mobile operator. And the mobile operator asked us, first of all, to find the way how intruders were able to intrude their network and how they were able to intercept SMS messages. Also, they asked us to find how many subscribers were affected and estimate approximate amount of all the fraud. So what we had at the beginning, this customer gives us access to their internal signal monitoring system. So we were able to see many events on their network. And also they asked us to reproduce the attack on behalf of real intruders from the external signaling connections. So what we found during our incident investigation. So first, what intruders should do, they should do some reconnaissance to receive information about subscribers. They already had information about banking accounts, and at this step, they need to link real phone numbers that belong to banking clients. So because all we are clients of many companies, both banks and mobile operators. At the next stage, that is resource development, intruders needed to get access to signaling networks. They acquire some infrastructure, and they got access to SS7, but not on a mobile subscriber, but on a fixed telephony operator. And despite this fact, they were able to have access to mobile operators due to trusted relationships between all operators around the world. At the stage of defense evasion, intruders needed to get access to some infrastructure nodes of the mobile operators, and particularly to HLR, that is a database of all mobile subscribers. They should bypass SMS home routing system that normally hides confidential subscriber identities. And to get a real identity. So after that, they needed to collect some information about their victim subscribers. They started collecting IMSI identities using this bypass technique, and using the situation that they got access to the HLR database. So, and only after that, when they had or collected information about their victim subscribers, they started impact the network. So at the first step of this impact, they needed to manipulate with some database, with HLR database. So what they did, they did fake registration of the subscribers in a bogus network via update location signal message and update location standard procedure. After that, they did the second step of impact. They tried to redirect user traffic from this mobile network. So this was several step impact. As the first step, intruders sent money transfer request via internet, via banking application, web or mobile, and the bank should initiate one-time password request via mobile operator. They did this via API connected to the mobile operator. So the next involved node was the SMS center that first of all needed to request real subscriber location. But since this subscriber location had been previously updated by intruders, so the HLR database replied with this fake location that was under the control of the attackers. And after that, the SMS center sent the SMS with one-time password to the attackers. And for sure, they were able to use this one-time password to confirm money transfer via the same application. So after that, my money transfer was confirmed and was done by bank to the accounts of the intruders. So what we get from this investigation, real case investigation. So first of all, intruders used a bypass technique to retrieve IMSI. They bypass real protection equipment. And since the network was protected, anyway, intruders were able to intercept one-time password short messages. The most interesting thing is that intruders used global title or source address that belonged not to mobile network, but to a fixed telephone network. And it was quite enough to get access to mobile networks and to execute all their actions, planned actions. For sure, since we know this global title, or source of these intruders, we share this information among all of our customers, just to inform, alarm them in advance that there is a group of hackers that can do many bad things. And the main recommendations was to improve security policies and security processes to get better vision on their network, on their security posture, and to get better the network protection. And as you can see, all these the long attack may be mapped to the MITRE attack matrix. So now the word to Kirill. Kirill, please continue.
Thank you, Sergey. So let's say we just observed two cases, right, about the 5G and the elder generation 2G, 3G, right? And you saw an attack evolving as a chain, right? And our main goal is actually to catch an intruder at whatever step, right? The earlier, the better, of course, before the actual impact stage happens, right? And so far, let's say we haven't found a better way to do this than like to take, let's say, all the threat-related information, right, that we get at Security Gen from our offensive testing, security monitoring, right, incident investigation, research, and collaboration with industry, and to form this kind of content, to process, analyze it, and integrate, right, and to process into some kind of knowledge base that can be very useful to the monitoring platforms, right, so that the helps to identify suspicious and some malicious activity that is going in the network, right? And of course, these monitoring platforms can create alarms regarding the issues happening in the network and communicate the incident information, right? So the same knowledge base is, let's say, used to actually transfer the knowledge from the monitoring system, for example, intrusion detection system, right, to the firewalls to specifically address like what kind of, let's say, rules should be implemented, whatever. And also is used for the same knowledge base can be used for like solutions like breach and attack simulation, where you proactively penetrate your network, right, in order to check like, your network is actually vulnerable to the known threats, right? So that you can actually emulate the activity before the real incident or attack happen. So and we can actually observe like how would this approach work on these two cases, right? If specifically these means would have been implemented into the network. So if we take the 5G denial of service case, right, that was shared with Igor, so we can, let's say, assume that the actual 4 stages of this attack chain, right, reconnaissance, resource development, initial access, and discovery, that these stages actually didn't trigger, right, any kind of security measures, because some doesn't even include, let's say, penetrating the network, some kind of intrusion, right, because like the customer needs to find open source tools, etc. So we just assume that these 4 stages already happened. And when we come to the collection phase, right, if we would have the, let's say, the monitoring implemented on the 5G, right, it will actually, we would have been able to detect an attacker on this phase, right, by IDS model of 5G IDS, right, and to receive the SIM or SOR personnel, SOC guys, they would have received an alarm about the activity, and they would have a chance to actually start implementing active measures, right, to prevent further activity. So start by, for example, blocking the source, right, addressing this information to the firewall, or actually go and isolate the specific threat, specific IP address the threat is actually coming from. So after that, they will have time to confirm that this is not legitimate IP, that is not generating, say, any kind of commercial traffic, etc. And that would actually, let's say, helped to prevent further activity and avoid the impact phase, right? And if you look at the incident investigation case, right, shared by Sergey, so here we also assume that the reconnaissance, resource development, and initial access stages, they already happened, right? So let's say the operator does not have any kind of influence, right, on the customer getting some SS7 connection or whatever, and as the roaming agreements are in place, somehow reaching the operator's network, right? But if we focus on the stage specifically where the penetration happens, right? And this is the defense evasion, right? So we have the attacker that is trying to get the information about the subscriber identifier. And we can see the situation where the SMS home routing solution is actually bypassed. So even if, let's say, we're not responsible for the SMS home routing functionality, right? This kind of bypass would have been, again, let's say, detected by the monitoring tools, right? By an IDS. Again, the SOC, SIM, SOR guys get an alarm about the activity. And again, they have a chance to take active measures on preventing the further activity, right? So again, start by blocking the source, investigate the activity, isolate the source of the malicious traffic, right? Take some time to analyze the SMS firewall rules, SMS home routing settings, and etc. And maybe even routing principle, because the bypass actually happened. But even if, let's say, this fourth stage, defense evasion, was skipped, let's say somehow, so the MNO would not have the proper defense measures, right? So the next stage, when the impact is trying to happen, basically, because it contains of several steps, right? The signaling part, where there is a fake registration in a bogus network, right? So this would have been, let's say, prevented by the signaling firewall that would not allow subscriber to register in a fake network if the proper, let's say, location check would have been performed, right? And would have shown that, for example, for the subscriber, it is impossible to move from one location to another one in that period of time, or something like that. So what we see here is basically the parts of the approach, right, that can be done in terms of building a security process, right? So, but I think one of the important steps is just not, let's say, dealing specifically, not waiting for the incident to happen and checking like how, let's say, the process and the team react, but actually do some kind of proactive job, right? So use breach and attack simulation models, right, to actually emulate the attacking activity and check how good the processes are. So like the goal of that is basically to test and to identify any of the exploitable vulnerabilities, right? So as this is an emulation, right? So from the monitoring tools will generate alarms, right? So the SOC, SIM personnel, they will have the chance to train in the blocking of the activity in isolation for the whole, let's say, within the whole infrastructure of the mobile network operator. And so this kind of, let's say, practice and simulations, they actually help to understand, let's say, how well prepared the operator and the security process in overall to the threats, right? And just to conclude this, right? So the idea of this all is to build the awareness around the knowledge base, right, about the threats and how correctly implement, let's say, existing defensive measures and what, let's say, extra measures are actually required. So if we look back into that matrix, MITRE FiGHT matrix, let's say one operator might ask, like, let's say, how well our personnel is actually prepared for these attacks and tactics. Because if you look at this table, right, it has a lot of tactics and attacks, and it might be concerning, let's say, different departments. And it's actually a question like how well the personnel, right, and the operator defensive measures are prepared for these kind of attacks happening. So we can let's say suggest, right, a solution of, let's say, combination of the threat detection, fast response, and continuous readiness, right, in order to actually proactively test the network security posture. So it's about threat detection, that your readiness to generate an alarm if some suspicious activity happening, right? It's about the correct settings and rules on the firewall, right, that actually proactively defend the network from the threats coming in, right? And of course, the verification and prioritization. So it's about the preliminary testing of the network before the actual incident happens, so that knowing, let's say, or what are the weak spots, prioritizing them, and actually getting your security better, right, to withstand potential attacks. So this is more or less it, and I think now we are open to the questions.
Yeah. All right. Thank you, Igor, Kirill, and Sergey. It was a very insightful presentation and webinar. And while you were going through the slide, there are a few questions which we have received. A few we've tried to answer in the panel, and few I'm going to pick up and share with the audience, and then Igor, Kirill, and Sergey can respond. So firstly, thank you everyone for being with us. And now I will start with the questions. So Sergey, the first one for you, I hope you can hear me very well and loud and clear.
Yes, I can.
So the question is, MNO you described had no firewall, right? And no IDS like monitoring, or that was bypassed. So that's a question from the audience.
Yeah. That's an interesting question. So the reality was that the mobile operator had some security policies. They didn't have firewall. They had SMS home routing that worked properly, but some configuration allowed to bypass it. Then, what about Telecom IDS? No, Telecom IDS also was not presented on that mobile operator, but the mobile operator had signaling monitoring system. But what we see, since the signal monitoring system allows to see much more than IDS can propose. But anyway, just a signaling monitoring system is not applicable for daily security monitoring, because it is maybe difficult to create filters, difficult to see, to present results and so on.
Okay. Thank you, Sergey. What I'm going to do, a mixed bag, so that after this, there's a question which has come up for Igor. Igor, the question goes, thank you for the informative simulation. By which app did you send this signaling message? Postman or Burp?
Yes, well, we use our product for testing. It's a breach and attack simulation platform for telecom ACE that support signaling protocols like SS7 stack, diameter for 4G network, and HTTP and PFP protocols that related for 5G network. So usage of this platform is also assuming of some simulation of new type of attacks, like for 5G networks that we presented today.
Thank you, Igor. There's one more question for you. So the question is, are the SMS interception attack applicable in 5G?
Yeah, it's a good question. So yeah, basically it's possible in case if such kind of functionality is supported by the operator. I mean, such kind of equipment is already installed and worked properly, like SMS function and supporting on UDM and on other network node.
Thank you. Another one for you, Sergey. You will have to bear with me. The question's a little longer. So it goes like this. The part of sending transfer money request is not clear. I mean, to initiate a transaction, you need to have access to your user's app. You need username, password of app. Then you need to add beneficiary to initiate a transaction. Did you mean that the user's app username and password is already discovered? Or you try to reset it via the OTP? Do you want me to repeat some part, or you could hear everything?
No. The question is clear. Yeah, this is an interesting question because when this kind of incidents happen, there are many talks about who is really responsible for these kind of attacks, bank or mobile operator. Here we see the really very complex attack that is done simultaneously on bank infrastructure and on mobile operator infrastructure. We were requested to investigate the case on the mobile operator side only, not on the bank side. And what we understand that these intruders already had credentials for mobile for banking accounts, and what they really needed to do for money transfer, this is getting the one-time passwords generated during each money transfer transaction. So that's why we started our talk from the disclosure of IMSI identity and intercepting of one-time passwords. So all other side was received via attacks on banking lines. Yeah, thank you.
Thank you, Sergey. Okay, one more for you, Sergey. This is a short one. How HR is bypassed?
So how home routing was bypassed? So what we could see that standard signal and messages sent to these mobile operators was routed to home routing, and if intruders used just standard messages, they weren't able to execute attacks. But they used one bypass technique. It was quite easy bypass, quite simple bypass. They used change of number and plan from the normal MSSDN to mobile global title E214 number plan.
Okay, thanks, Sergey. The next one is for you, Kirill. And the question is, through signaling firewall, 4G, 5G threat intel can be automated. That's the question. There's another one. Is there any benchmark like NIST, MNO should follow?
Mm-hmm. Yeah, thank you. So regarding the automation, right, of the threat intelligence, it's all about, let's say, the process that is built with between the vendors and the company itself, right? So Because the threat intelligence may come in different ways. It may come with a firewall update, right? Because the new, for example, threats have been detected, and now the firewall actually requires, let's say, the more sophisticated rules, and there is an update to actually support that. Or, for example, the threat intelligence is being shared within the group as some, let's say, list of malicious sources, right, that you should add to your blacklist. So not to wait before, let's say, some intruder actually bypass some security means, right? So it's all about cooperation. But when we speak about the, let's say, some kind of approach should be followed like NIST. NIST is related to the process again. It's not like just we talk about the firewall. And the approach actually can be, let's say, relying on the one that we actually suggest, right? So it's about the threat identification, the fast response, so about the defensive means, right? And also the threat validation and prioritization. So when you test your network, you understand your weak points, you prioritize, and actually work to make your network more secure.
All right. Thank you, Kirill. There's one last one I see for Igor now. And the question, Igor, is, did you see any recent incident in 5G core? Are any new vulnerability findings there?
Yeah, there is the fact that 5G network are only being deployed into production around the world. Our customers have not yet had real incident cases, but during the testing process that we performed with our customers, we already seen some misconfiguration and error implementation on the vendor equipment, and see some misconfiguration of how the network is working. It's not what was properly, like it could be by the regular documentation.
Okay, thank you, Igor. Kirill, I see one more popping up for you. And the question is, let me read that aloud. 5G standalone, which is secured by design, reference to SEPP, would be interesting to know your vision on 5G SA vulnerabilities and need of extra 5G standalone firewall. What's your thought on this?
So yeah, good question. So let's say, firstly, let's discuss the first part, right? Secure by design. So as you know, the industry actually trying to do this, let's say, secured by design things for some years already, but let's say it doesn't always work, and I may, let's say, take the responsibility to say that it doesn't work very frequently, right? And for the situation as of now, right, there are not many actually 5G standalone networks that has the roaming in place and that have the SEPP working in place, right? And if we talk about the SEPP, its main function is basically, first of all, to perform the routing, right, and to perform the ciphering of the traffic. But actually, who knows what potential threats, right, might be hidden in this. And speaking about the extra firewall still to be added, let's say my opinion is, yes, probably the extra firewall would be required, just not to rely on the SEPP. So, and probably in the nearest years, we're going to see the vendors not only bringing the SEPP and some kind of combined solution, but also the vendors that are coming with the standalone firewall for, let's say, specifically protecting the network. Because even during the specification being built, right, actually the holes, right, and the one just as Igor, for example, explained, they appear, right? And well, for sure, time will tell, but we shouldn't, let's say, really rely on the secured by default. And of course, once the roaming is there and we have multiple connection 5G to 5G standalone, it's going to be, let's say, more field to test, right, and to actually to answer this question appropriately.
Thank you, Kirill. Well, this was the last question. We are also coming close to the end of the session. So thank you, Kirill, Igor, and Sergey for the insightful presentation. Thank you, everyone who joined us today. It was really good engaging with you and all the questions that we addressed. But before we say a bye to you, I'm going to reiterate that after this session, we are going to share with you a copy of the slides and the webinar recording in your email box very soon. You will also have our contact ID, so you can reach out to us for a follow-up question and answer session. And you can also reach out to Kirill, Igor, and Sergey individually to get your queries addressed. But this is a very good session. Thanks for joining, and thanks for being a wonderful audience, everyone. Thank you so much. Bye for now.
Thank you for your attention.